All right, guys, last lesson we looked at the first of our physiological response measurements, and we looked at our EEG, the electroencephalograph, which detects, amplifies, and records the electrical activity of the brain. Today we're going to be looking at the EOG and the EMG. So starting with our electromyograph, also known as our EMG. Again, you need to make sure in your definition that you specify that it detects, amplifies, and records, this time the electrical activity of muscles. And if you have a look at the word here, electromyograph. Again, if we break that word down, electro, the electrical activity. Myo means muscles. If any of you see a myotherapist, you are going to see a muscle therapist. And graph, because that's what we're trying to do, is produce an image from this. So specifically, when we're looking at an electromyograph, we're looking at the measurement changes in muscle activity and muscle tone. And muscle activity is the movement of your muscles, and muscle tone is the tension. So you can see in this picture here, this person is quite tense. They're holding their biceps nice and tight. And they're not necessarily moving while they hold that, but as they're putting themselves into that position, that would record the movement. And as you can see in that picture as well, the electrodes are attached to the skin above the relevant muscles. So there you can see there's an electrode here and here on the bicep and over here on the wrist. And it just depends on what sort of measurement you're trying to take as to where you will put those electrodes. And you end up with an image very similar to an EEG. So again, you're going to be looking for the amplitude and frequency of those waves. The higher the amplitude and the higher the frequency, the more activity and tone you are recording. So here you can see another image. This particular one is a little different. This one's got a needle that goes into the muscle. Now we don't use that for states of consciousness, but other disciplines of science will use it. So this particular one is looking at neuromuscular disorders. And the EMG is really looking at showing our states of consciousness in the following ways. So when we fall asleep and as we relax, you will get that reduced muscular tone. So you will see that both the amplitude and frequency will get lower as we are falling asleep. So that's an indication of our consciousness as we are entering an ASC, an altered state of consciousness. Also, you'll have distinguishable periods where muscles can spasm, such as in light sleep. There's a little thing called a hypnojerk, and we're going to look at that when we go into sleep, but that's basically your muscles spasming as you fall asleep. And then there's other periods where your muscles are in a completely relaxed state, such as deep sleep, where you're not even moving at all. So overall, higher muscle tone and muscle activity will indicate being more alert and vice versa. So lower muscle tone and low muscle activity indicates being less alert. The electrooculograph, the EOG, again, a device that detects, amplifies, and records electrical activity, but in this time in our eye muscles. So if we break this word up again, electroocular graph, electrical activity, ocular referring to eyes, like a binocular or monocular, and then again that graph. And we're looking at the eye movement in this case. So it measures eye movement and eye positions. And you can see electrodes get placed not on the eye itself, but around the eye. And it's detecting muscle movement around your eye. So it's most commonly used to measure changes over time during different types and stages of sleep. In particular, what you're looking at is rapid eye movement sleep, or REM sleep, and non-rapid eye movement sleep. So these names literally refer to your eye movement. So when you're in REM sleep, your eyes are rapidly moving constantly. And when you're in NREM sleep, which we're going to look at in more detail when we do sleep, your eyes barely move at all. And here you can see the graph that we get from an electroocular graph. And you can see here, this is your left eye, and down here is your right eye. And hopefully what you're noticing is they're mirror images of each other. So as one eye is tense, the other eye is relaxed. So they're going in opposite directions. So if this eye is moving to the left, this eye is doing the opposite. It's also moving to the left, but what's happening is that you're trying to record the information on a different part of your face. So they're going opposite. All right, learning activity 8.9. You've already done questions 2 and 3 from last lesson. Question 1 is quite an involved one. It says you need to construct a table that summarizes the 3 devices. I want you to put detail into this. You should be able to not just know the name of the device and what it measures, and when you say what it measures, I want those definitions in there, but the examples of responses and how that relates to both the alertness and the state of consciousness. So in there it says SOCs. SOCs refers to the state of consciousness.